All right, let's dive into this. Yesterday on day 18, we saw how nodes use heartbeats to check who's alive and kicking. But that's only half the story, right? What's the point of knowing your buddy is online if you can't actually talk to them?
So that's the real question, isn't it? How does a system with thousands, maybe even tens of thousands of servers share secrets and keep everyone on the same page when there's no boss, no central coordinator calling the shots?
Okay, so when you're faced with a problem like this, where do you even start? Well, usually you go for the most obvious solution, the one everyone thinks of first. Let's talk about why that's a huge trap.
The simple approach? You just pick one server and make it the manager. Yeah, you give it all the power, it keeps track of absolutely everything, tells all the other worker nodes what to do. Sounds easy enough, right? What could possibly go wrong? Wrong. So wrong. This simple idea is precisely how you design a system that's doomed to fail spectacularly. See that manager node? It's what we call a single point of failure. It's a ticking time bomb. It's not a question of if it will crash, but when. And when it does, the whole system gets amnesia. Instantly. The entire cluster just goes completely blind. Nobody knows who's alive, who owns which piece of data. It's absolute total chaos. So here's the big takeaway. The obvious solution just does not scale. It's brittle. So now let me let you in on the architectural secret that powers some of the biggest, most resilient systems on the entire planet.
We do the exact opposite. Instead of one node doing all the talking, we let everybody talk.
This, my friend, is called the gossip protocol, and it is so brilliantly simple. The idea is instead of one manager broadcasting to everyone, every single node just, gossips with a few of its neighbors. And here's the kicker. The rules are ridiculously simple. You ready? Rule 1. Every node keeps a little list of all the other nodes and what it knows about them. Rule 2. Every second or so, each node just randomly picks a few other nodes. And Rule 3. It tells them everything. It just dumps all the information it has. That's it. Now, what's really cool is how this plays out visually. I want you to picture this. Imagine a huge, dark grid, just filled with thousands and thousands of tiny little glowing nodes. Okay, now watch. Imagine one of those nodes way off in a corner suddenly turns a bright neon yellow. It just learned something new, a secret. Maybe it found out another node just went offline. So what does it do? It doesn't shout. It just whispers that secret to, say, 3 of its neighbors, chosen completely at random. And boom, just like that, now 4 nodes are glowing yellow. And then what happens? The very next second, those 4 nodes each tell 3 more random nodes. And then those new nodes turn around and tell 3 more. You see where this is going? It's an epidemic of information. In just a matter of seconds, you see this incredible wave of yellow light just wash across the entire grid. It spreads exactly like a harmless but super infectious virus. And just like that, everybody knows the secret. Now, this beautiful, elegant chaos, it almost sounds too good to be true, right? And you'd be right. There is one really important trade-off you absolutely have to be okay with. It's a concept called eventual consistency. And what that means is, for a very brief moment in time, the information isn't perfectly consistent across the whole system. The nodes on one side of the grid might not have gotten the news yet. But, and this is the key, eventually they will. Given just a little bit of time, everyone converges on the same truth. So what are they actually gossiping about? Well, it's stuff exactly like what we talked about yesterday. Each node is gossiping its own membership list, complete with those heartbeat counters. So if one node sees that, hey, the heartbeat counter for node S2 hasn't been updated in a while, the rumor starts. Pissed, hey, I think S2 might be down. And look, this is not just some academic theory. This is real-world, battle-tested stuff. Massive, leaderless databases like Apache Cassandra, they are built on this. They use gossip to figure out cluster membership, to detect failures, and to track which nodes own which pieces, or shards, of the data, all without a single fragile masternode in sight. Okay, let's step back. Our nodes can now talk to each other without a master. That is incredible. We've built a resilient, decentralized system. But solving one problem in distributed systems almost always creates another, even trickier one. Think about it. What happens if 2 different nodes on opposite sides of the world try to update the exact same piece of data at the exact same millisecond?
Who wins? How do you resolve that conflict? Well, that's what we're tackling tomorrow. On day 20, we are diving deep into something called vector clocks, which is how we solve these crazy data conflicts. So make sure you hit subscribe. You are not going to want to miss this.